Next sequence is y of n is it's a bit kind of different problem. So I need to find y of n, and what is y of n? Y of n is x of n convolved with h of n. Okay, and where x of n is this sequence and h of n is this sequence. So again we have to use actually convolution property of the transform. We'll see how do we do that. So solution. Okay, before the solution we'll see the property of convolution, right? What is the property of convolution? What is the Z transform of x1 of n convolved with x2 of n? It is x1 of z multiplied with x2 of z, right? Okay, in our case x1 of n is x of n and x2 of n is h of n. Okay, so x of n is equal to, what is the z, we'll take z transform of, okay, let me write like this: z transform of, what is the z transform of x of n convolved with h of n? This is nothing but x of z multiplied with h of z, right? So we have x of n, and what is x of n? X of n is this sequence. We have h of n, and what is h of n? H of n is this sequence. So what do we do here? We'll take z transform of x of n, we end up with x of z. We take z transform of h of n, we end up with h of z. So we multiply x of z and h of z, okay, which is nothing but, we call this multiplied sequence as y of z. Let me write it here. We take x of n, sorry, we have x of n, we take its z transform, so we end up with x of z. We have h of n, which is this sequence, we take its z transform, we end up with h of z. Okay, so what I'll do, I'll call an intermediate signal y of z, which is nothing but x of z multiplied with h of z. Okay, now if I take this sequence inverse z transform, fine. So what is the inverse z transform of y of n? It is, sorry, y of z, it is y of n is equal to, what is the inverse z transform of x of z multiplied with h of z? If the z transform of x of n convolved with h of n is multiplication, its inverse z transform is what? I have to go back. It is nothing but what? X of n convolved with h of n. Okay, and that is what I mean. I need to find y of n is equal to x of n in, convolved with h of n. That is what I need. Fine. So this is what I am following now. First I'll take z transform of x of n, and then I'll take z transform of h of n. I multiply those two sequence and call it as y of z, and I'll take inverse z transform of that. Whatever the right hand side sequence I get inverse z transform, that will be my convolution sequence, which is y of n. Fine. Okay, so first we'll find x of z. What is x of z? Z transform of x of n. Okay, and what is the z transform of x of n? This is nothing but z transform of this z transform of this, and z transform of this. What is the z transform of delta of n? It is 1. Plus, what is the z transform of delta of n minus 1? It is z power minus 1. Plus, what is the z transform of 4 times delta of n minus 2? It is nothing but 4 times z power minus 2. Right? Because z transform of what? Delta of n minus n naught is nothing but z power minus n naught. So that's why z power minus 1, n naught is 1 here, n naught is 2 here, so z power minus 1 and z power minus 2. Fine. So this is magnitude of z greater than 0, magnitude of z greater than 0, magnitude of z greater than 0. So the whole ROC's magnitude of z is greater than 0. Combined ROC's, I should not forget the ROC. So here for this sequence, ROC's magnitude of z is greater than 0. Okay. So similarly, h of z is equal to z transform of h of n. This is equal to, what is, okay, we shall write this h of n in terms of sequence. What is h of n? H of n is what? It is varying from 0 to 2. From 0 to 2 it is 1 by 2 power n, and otherwise it is 0, right? So when n equal to 0, it is 1 by 2 power 0, which is 1. Okay, this is at n equal to 0, so I have put an arrow mark here. When n equal to 1, it is 1 by 2 power 1, which is 1 by 2. So when n equal to 2, it is 1 by 2 power 2, which is 1 by 4. Okay, this is the h of n. So how can I write it in delta function? It is nothing but delta of n plus 1 by 2 times delta of n shifted right 1 time plus 1 by 4 times delta of n shifted right 2 times. This we have discussed in the previous video, right? Okay, so what is the Z transform of delta of n? It is 1 plus what is the Z transform of 1 by 2 delta of n minus 1? It is 1 by 2 times Z power minus 1 plus 1 by 4 times Z power minus 2. Z transform of 1 by 4 into delta of n minus 2. Again, what is its ROC? ROC is combined ROC, magnitude of Z is greater than 0. So it's a finite length right sided sequence. It's a finite length right sided sequence. So ROC of a finite length right sided sequence is magnitude of Z is greater than 0. Okay. So we got x of z, which is this. We got h of z, which is this. So what is our next step? Our next step is to find y of z, which is equal to what? X of z multiplied with h of z. X of z is 1 plus z power minus 1 plus 4 into z power minus 2 multiplied with h of z, 1 plus 1 by 2 into z power minus 1 plus 1 by 4 into z power minus 2. Okay. So if we multiply and simplify it, I am not simplifying it, so it takes more time in the video. So I'll directly write the result: 1 plus 3 by 2 z power minus 1 plus 19 by 4 z power minus 2 plus 9 by 4 z power minus 3 plus z power minus 4 with ROC does not change, greater than 0. Fine. So I did till here. I'm done with till here. Okay, I got y offset sequence. What is the next step? This is not my solution. What I need to find is y of n, but I found y offset. How to get y of n? If I get y offset, I just have to take inverse Z transform, right? Okay, so I'll put it in the next page. So we have y of z as 1 plus 3 by 2 z power minus 1 plus 19 by 4 z power minus 2 plus 9 by 4 z power minus 3 plus z power minus 4. This is our y offset. If I take inverse Z transform on both sides, so what is the inverse transform of y offset? It is y of n. Okay, is equal to, what is the inverse transform of 1? Delta of n. What is the inverse transform of 3 by 2 z power minus 2? It is plus 3 by 2 remains constant. Z power minus 1 is what? Delta of n minus 1 plus, this is nothing but 19 by 4 delta of time shifting property, right? Z power minus 2 is delta of n minus 2 plus 9 by 4 delta of n minus 3 plus delta of n minus 4. If Z transform of delta of n minus n naught is Z power minus n naught, so if I take inverse Z transform of this, that will be nothing but delta of n minus 2 naught. That's what I used here. Okay, fine. So if I write it in terms of sequence, what do I get? So delta of n is 1, comma, next sample is 3 by 2, comma, 19 by 4, comma, 9 by 4, comma, 1. At n equal to 0 is this. So this is the sequence y of n we got. Okay, which is nothing but x of n convolved with h of n. Basically, I mean, I can cross check this answer. It's better we should know how do we cross check whether what we did is right or not. Okay, what is our x of n sequence? X of n sequence is 1 comma 1 comma 4, right? And what is our h of n sequence? H of n sequence is 1 comma 1 by 2 comma 1 by 4. Okay, so it is 1 1 4 and it is 1 1 by 2 1 by 4. So what do I need is y of n, which is equal to x of n convolved with h of n. And I taught you the shortcut method of performing the convolution in the previous video, but you can refer the convolution sum part of our video. There I have taught you how to solve this problem in a direct method, but we will do this here. So how do we do it? First sequence I have to take it in a row wise, and the other sequence I need to take it in a column wise. 1 1 by 2 1 by 4. So anything is fine. Any sequence you can take it as row or column, because convolution holds good commutative property. Now I need to what do I need to do? I need to multiply this. 1 into 1 is 1, 1 into 1 by 2 is 1 by 2, 1 into 1 by 4 is 1 by 4. Similarly 1, 1 by 2, 1 by 4, 4, 4 by 2 is 2 and 1. Okay, now I need to add these sequence. Therefore I get y of n as this is 1, 1 which is matching, and what is 1 plus 1 by 3? 1 by 2, it is 3 by 2 which is matching. And what is 4 plus 1 by 2 plus 1 by 4? We get 19 by 4. You just check it. And 2 plus 1 by 4 is 9 by 4, and the last sequence is 1. Okay, we'll take up one last problem on Z transform using properties. So here I need to find x of infinity. So x of infinity for the two Z transform sequence. X of z is this and x of z is this part. Solution, we'll try to solve this. We have final value theorem. I'll just give you the statement of the final value theorem. It is given by x of infinity is equal to limit z tends to 1 z minus 1 times x of z. So this is the statement of final value theorem which we are going to use here to solve x of infinity. Okay, we'll take up the first problem. X of z is equal to z plus 2 divided by z minus 0.8 whole square. Okay, what is x of infinity? X of infinity is equal to what? Limit z tends to 1 z minus 1 times x of z. So x of infinity is equal to limit z tends to 1 z minus 1 times what is x of z? X of z is z plus 2 divided by z minus 0.8 whole square. Now if I apply the limit, x of infinity is equal to 1 minus 1 into z plus 2 divided by z minus 0.8 whole square. So this becomes 0 because 1 minus 1 is 0. So we get therefore x of infinity is equal to 0. Okay, so next the second one, what do we have? X of z is equal to z plus 1 divided by 3 times z minus 1 into z plus 0.9. So x of infinity is what? Limit z tends to 1 z minus 1 times x of z. But what is x of z? Z plus 1 divided by 3 into z minus 1 into z plus 0.9. So z minus 1 cancels out. If I apply the limit, x of infinity is equal to z is 1 plus 1 whole divided by 3 into 1 plus 0.9 is 1.9. So this ends up with 2 divided by 3 into 1.9. This is 0.35.